Hey everybody, this lesson is to get you ready for absolute value kind of problems on the new SAT. And if you guys want to sign up for our class, you can go to www.b&btestprep.com and give us an email and all that stuff. All right, let's review some absolute values, you guys. Absolute values always has two parts to it. There's a positive part and a negative part. So for example, if we had the absolute value of x equals 3, then by plugging in -3 and +3, it would get us equal to 3. The absolute value of -3 equals 3, and the absolute value of +3 equals 3. So we can say x equals plus or minus 3. Okay, it's like distance from 0 on a number line. What numbers are 3 units from 0 on a number line? That's what absolute value represents, is just how far away from 0. So using this right here, the absolute value of x equals 3 gives us x equals plus or minus 3. We can do that with the absolute value of 2x minus 1. If that equals 13, then we can just set that 2x minus 1 equal to plus or minus 13. And so then that gives us two equations. 2x minus 1 equals 13, or 2x minus 1 equals negative 13. Whoops, I did the negative 13 first. And then just solve these. Plus 1, plus 1. Here we'll do plus 1, plus 1. And then we'll divide by 2 next, and we get negative 6 or 7. Okay, so if we plugged in negative 6 right here, 2 times negative 6 is negative 12. Negative 12 minus 1 is negative 13, and the absolute value of negative 13 is 13. And if you plugged in 7, you'd also get 13 right there. Okay, so if we have something like this, you guys, the absolute value of y plus 3 equals 17, then we just set it equal to plus or minus 17, the inside piece, and then solve each one, and you get negative 20 or 14. All right, how about this one? Make this equal to plus or minus 9. Okay, and then we'll subtract 5 and then divide by 2, and you get that as your answer. Okay, what about this one right here? Okay, now if it was equal to negative 7, then we would say there's no solution because an absolute value is always positive. It can't be negative. But since that's a variable right here, that means x has to be negative to get a negative times a negative is a positive right here. So an absolute value equals this negative 7x. X is going to have to be a negative number. So go ahead and solve it with your plus or minus piece like we did. And then remember, we just want the negative one right there. So we're going to go ahead and subtract x on both sides, and then now we're going to divide this one by negative 8, this one by 6. So we get x equals negative 3 or 4. Well, remember, we want the negative one. The only one that will make this a true statement to be positive is when x equals that negative 3 right there, okay? All right, so what if we had the absolute value of x is less than 3 or less than or equal to 3? These are the same, mathematically the same, except this is an open circle and this is a closed circle right here when we graph it, okay? So absolute values sometimes treated as distance from 0 on a number line. So here that means that all numbers that are less than 3 units from 0, or in this case less than or equal to 3 units from 0 on a number line. So your graphs would look like that right there. All of these points in between negative 3 and positive 3 all satisfy this inequality right here. All of these between negative 3 and positive 3, including negative 3 and positive 3, would satisfy this guy right here. Okay, and then so the algebra answers for these, for this one, is negative 3 is less than all of these x values is less than positive 3. Over here, let's use the same thing except less than or equal to right there, okay? All right, and then these are also, they're called AND statements, so we can represent these as AND statements. AND statements can be written as shortcut ways. We'll do when we get to the next ones here. OR statements can't be, but let's try a couple of these here, you guys. So when we're solving absolute value of x is less than 3, we get negative 3 less than x less than 3. Or less than or equal to if we're using this one right here. Okay, so let's do that method and solve this guy right here. Okay, since it's less than 9, like this one is less than 3, I'm going to set it up just like this. We're going to put the x stuff in the middle, the 2x plus 1 stuff in the middle, put negative 9 on the left and positive 9 on the right. Remember, there's always a negative and positive part to that. Okay, now plus 1, plus 1, plus 1. We've got to add 1 to all 3 pieces right there. Divide by 2 from all 3 pieces, and there's our answer. So any number between negative 4 and 5, any number, can't be in this case negative 4 or 5, because it's just less than right there, okay? All right, so if we had greater than, you guys, it means all the numbers that are greater than or equal to 3 units from 0 on a number line. So your graphs would be this. So here's -3. All of these are farther greater than 3 units from 0, and same with this side. They're all farther than 3. This is just greater than or equal to or less than or equal to. This side says less than or equal to -3. This side says greater than or equal to +3. Okay, if there's a gap in the middle, if it's greater than your absolute values, then we got to write this as a or statement, you guys. So here, this side says x is less than -3 or x is greater than +3. This is the same except for the equals bars right there, okay? And there's no shortcut way to write these by putting x in the middle. If it's a greater than, then you got to say the or statements on these, okay? We're going to use that method right here to solve this guy right here, okay? So I'm going to say 4x plus 5 is less than -13, or 4x plus 5 is greater than +13. Okay, and then we just solve each one, divide by 4. So as long as we get any number that's less than -4.5 or any number that's greater than 2, that would work for this situation. All right, let's try a couple more that work for the SAT. So here, z is less than 0. That just means negative, you guys. And the absolute value of z minus 5 is equal to 5. What is the absolute value of z? Okay, well, that negative, this guy right here says we want the negative part. So then we'll plug that into this part, and it's going to make it a positive answer right there, okay? So, but we're focusing on just a negative. So solve this, you guys, just like we did before. We're going to make it equal -7 and +7. We get -2 and 12. Now remember, this says we want the negative part. So we want z equals -2, so then what is the absolute value of z? The absolute value is going to be +2. All right, so how about this? For all numbers x, y, and z, or x and y, I'm sorry, let z be defined by this equation. Z equals the absolute value of 2 squared minus x squared minus y squared plus 2 squared. I don't know if you can hear the birds in the background. We have lots of bird feeders in our backyard, and I'm sitting in my living room right now. Anyway, so what's the smallest possible value of z? Okay, well, so now I know it's going to be a positive because we got an absolute value right here. So this absolute value right here, we can minimize this by making this equal to 0. And can we make this equal to 0? 2 squared minus something squared minus something squared? Yeah. Here's an example right here. If we let x be 0, and then let y be 2, then we get 2 squared minus 0 squared minus 2 squared. This would be 0 right here. This is always going to be plus 4 right there. So can we make, what's the minimum value we can make on this right here? The smallest value we can make z when this is 0. So when this is 0, 0 plus 4 is 4. So what's the smallest possible value? 4. All right, okay, so this one. Let f be defined by 2 minus the absolute value of x minus 4 for all real numbers, values of x. What is the greatest value of x? Okay, well, the greatest value of x is when we subtract the least number right here, okay? This is always positive no matter what. So when can we make this the smallest? When it's 0 right here. So this function has a greatest value when this absolute value is minimized right here. And we can make this absolute value 0 by just letting x be 4, okay? And that's going to give us 2 minus 0, which is 2. So the greatest value of f is when this is the smallest, and we can make this the smallest when this is 0, so the greatest value is going to be 2. Okay, now remember how graphing this right here, this would be graphing a V. It would be an upside down V right there. It would be going like that. Okay, and it would max out at that 2 right there. Okay, all right, so this one's a tricky one here. So on a number line, number p is more than twice as far from -3 as it is from 3. Which of the following inequalities can be solved to find all possible values of p? Okay, so check this out, you guys. The expression absolute value of x minus a just means the distance between x and a on a number line. Okay, well look, we got some plus 3's here. here's the distance from P and 3 on a number line right here, okay? All right, so when we see, for example, the distance between 3 and 9 is 6. We know it's 6, okay? So it's either the absolute value of 3 minus 9 or the absolute value of 9 minus 3. They both give us 6 right there. But when we see something with a plus sign in it, an expression like x plus a is the same as x minus a minus a, and so that just means it's the distance between x and negative a. This right here says it's the distance, this absolute value means the distance between x and negative a. Okay, right here, this is the distance between x and a. This is the distance between 3 and 9. So this is the distance between x and negative a. So this right here would be the distance between p and negative 3. You with me? I hope so. So translating the problem above right here, it says p is more than twice as far from negative 3 as it is from 3. Well, that means the same thing as the distance between p and negative 3 is more than twice the distance from between p and 3. Okay, let's put that together right here. The distance between p and negative 3. Okay, that's going to be the absolute value of p minus a minus 3, which is p plus 3, is more than, so greater than, twice, so there's going to be a 2 with the absolute value of p and 3. So it's sure looking like choice B right there. All right, you guys, I hope that makes sense, and take care.